Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 284. Page 284, and today is our lesson number 132. Problem number 103 is what we are about to do. In problem number 103, we are told that we have letters arranged in 9 cells, 3 by 3 arrangement, where each letter, we are told, can assume a value of either a 1 or a 2 or a 3, and nothing else. We are also told that each number can occur only once in a given row or a given column. In other words, repetitions are not allowed. The question simply is, how much is R? And this is the arrangement that they give us. R, S, T, U, V, W, X, Y, and Z. Well, let's see what they give us in the first statement. In the first statement they tell us that V plus Z equals 6. Let's think about it for a second. V plus Z equals 6. And since these are integers, how can we make the sum of the two integers equal to 6? Well, is it possible to have 0 and a 6? The answer is no, because for one thing, to start out with, we are not allowed to have a 0, only 1, 2, and 3. And if V were 0, Z would end up being, even if 0 were allowed, it's a hypothetical statement, 6 is not allowed. We only allow 1, 2, and 3. So that's not possible. Is it possible for V to be 1? Yes, V can be 1 because we are allowed 1, 2, and 3. But then if V were 1, it's a hypothetical statement again, then Z would have to be 5. Because we are told that their sum is 6. But we are not allowed 5, it's only 1, 2, and 3. So that's not possible. Is it possible for V to be 2? Why not? We are allowed 1, 2, and 3. Again, if V were 2, Z would end up being 4. Because it has to add up to 6. Since we are not allowed 4, we are not allowed 5, we are not allowed 6, which means that these variables. Now, when it says V plus Z, this is no different than Z plus V, which means that neither Z nor V can be 1 or 2. Because if either of those were 1 or 2, either Z or V is 1 or 2, the other one will end up being 5 or 4. We are not allowed 5 and a 4. They can only go up to 3, which means the only possible values for Z and V are 3. This implies that both V and Z must be 3. That's the only option. They cannot be 1 or 2. Neither V nor Z can be 1 or 2 because the other one will end up being either 4 or 5. And we can't have 4 or 5. So we know that V and Z must be 3. Let's put them in here. V and Z must be 3. This is 3, V is 3, and we know now that Z is 3. These are fixed. This is fixed. This cannot change. We know for a fact they are 3. Okay, now let's begin our story. If V is 3, and since we are told that we can use only 1, 2, and 3 in a given row or a column, it's not in a given row or column, but we are told that each number can assume a value of 1, 2, and 3, and each number can occur only once. Each number can occur only once. We already used up 3 for V here in the second row. We already used up 3, which means either U is 1 and W is 2, or U is 2 and W is 1. Those are the only two possibilities for U and W. Similarly, if Z is 3, then either Y is 1 and X is 2, or X is 1 and Y is 2. Again, those are the only two possibilities for X and Y. X and Y can take a value of either 1 or 2 because 3 is taken. 3 is taken. And in each given row, we cannot have any repetition. Since 3 is already used up, it's either 1 or 2. Now let's talk about this and this. If U is 1, X has to be 2. Why? Because if U is 1, then in the given column, we cannot have another 1. Repetition is not allowed. Similarly, if U is 2, then X would have to be 1. But that's not the part that interests us. The part that concerns us, this part we just did, was not necessary. The part that concerns us is that U can be either 1 or 2, x can be either 1 or 2, which means r has to be 3. R must be 3. Why? Because we have 3 numbers, 1, 2 and 3, and 3 places to fill. Since there are 3 places to fill and only 3 numbers and no repetitions are allowed, each number has to be used. We cannot put 2 or 1 here because 2 or 1s are used here. One of these guys is 1, the other one is 2. So we cannot use 1 or 2 in this column because no column can have repetition, therefore R must be 3. Therefore the first statement is sufficient by itself. The first statement is sufficient by itself. The first statement is sufficient by itself, therefore A, D, B, C, E. Since the first statement by itself is sufficient, the answer cannot be B, C or D. It will have to be either A or a D. Now, the other way, there is another way we could have figured out what R is. And if you're interested, I can show it to you. It's just a different way of looking at the whole thing, a different perspective. There is another method that we could have employed to figure out R. I'm going to quickly show it to you. Here how it goes. R, S, T, U, V, W, X, Y, and Z. Now, I'm not going to redo all the work. We already did all the work, and based on the statement number one, we know that this implies that V is equal to 3 and Z is equal to 3. So let's put them here. V is equal to 3. And Z is equal to 3. Okay, now listen carefully, see what happens here. Because we are told that no number can be repeated in a given column, each column can have a number appearing only once. Because 3 already appeared here, that means 3 cannot appear in the second column. Similarly, because 3 appeared here, for V, 3 cannot appear in the second row. It cannot appear here. Similarly, because 3 has appeared here, Z is equal to 3, because 3 has appeared here, 3 cannot appear in this column. In other words, 3 cannot be here or here. Similarly, because 3 appears here, it cannot be in the last row, any other cell. It cannot be here or here. Which means the only place that 3 can appear would be R. Why? Why does R have to be 3? Just because, listen carefully, just because 3 cannot appear in any of these, just because 3 cannot appear again in the second column because it already appeared here, and just because 3 cannot appear in the third column because it appeared here, Z is equal to 3, and just because 3 cannot appear here anywhere else, why does that make R, why is it true that R must be 3 then? Because R has to appear in this column, in the first column or the first row, however you want to look at. If you look at the first column or the first row, because R cannot appear here in the second spot, because R cannot appear here in the third spot, R has to appear somewhere in a given row. In a given row, all 3 numbers must be used, because we have only 3 numbers, 1, 2, 3, and 3 spots to fill it in without repetition. Since we only have 3 numbers, 1, 2, and 3, then 3 spots to fill with no repetition, each number must be used. But R cannot appear here, 3 cannot appear here, 3 cannot appear here. Similarly, 3 cannot appear where U is, 3 cannot appear where X is, because 3 cannot appear where U is because 3 has already appeared here, so in the entire row 3 cannot appear again. Similarly, 3 cannot appear where X is because Z is equal to 3, which means the entire third row 3 cannot appear again. And every column must have all of those 3 numbers used up. Since 3 cannot appear here and here, this must be 3. Similarly, 3 cannot appear here and here, it cannot be S or T. In a given row, 3 must appear once. Therefore, R is 3. That's another way of analyzing it. You understand? Anyway, the bottom line is the first statement is enough. The bottom line is first statement is enough. Let's take a second statement. In the second statement, they tell us that S plus T plus U plus X equals 6. Again, R, S, T, U, V, W, X, Y, and Z. S plus T plus U plus X equals 6. But we know that each column, let's put it here, each column and each row must add up to 6. Why does each column and each row must add up to 6? Again, because there are 3 spots, because we have 3 spots for each column. Each column and each row has 3 spots, and we have only 3 numbers. So it's 1, 2, or 3, or 1, 3, and 2, or 3, 1, and 2. However you arrange them, there are only 3 numbers, and no matter how you arrange them, they're going to add up to 6. 3 plus 1 plus 2 plus 3 is 6. And those 3 numbers, regardless of how they appear in a given column or a given row, each column will always add up to 6. Are you with me? Which means this first column, R plus U plus X, equals 6. It also means that the first row, R plus S plus T, R plus S plus T also equals 6. Because R plus S plus T equals 6 and R plus U plus X equals 6, therefore R plus U plus X must equal R plus S plus T, which implies that U plus X must equal S plus T. U plus S, U plus X must equal, in other words, these 2 numbers must equal these 2 numbers. What do we gather from that? These 2 numbers must equal, U plus X must equal S plus T. That means X plus X, U plus X must be 3 and S plus T must be 3. Why? Why is that? Because U plus X and S plus T cannot be anything, they cannot add up to anything other than 3. Can they add up to 2? How can they add up to 2? How can U plus X be add up to 2? The only way U and X can add up to 2 is if they are 1 plus 1. But they cannot be 1 plus 1 because they appear in the same column. They have to be different numbers. If they have to be different numbers, the only possibility is 1 and 2, or 2 and 1. Why is that? Because they cannot be 1 and 1. That's the only way they can be. They can be equal to each other here. Because they have to all add up to 6. Because they all have to add up to 6. This way they're going to be only 4. So if the sum of this guy is equal to sum of this guy, and if they have to add up to 6, the only way it is possible is this guy is 3 and this guy is 3. Think of this as 1 unit. S plus T is 1 unit, U plus X is 1 unit, and this unit plus this unit adds up to 6, which means this unit has to be 3 and this unit has to be 3. How can it be 3? How can S and T how can S add up to 3? Well, there are only 2 possibilities. Either S is 1 and T is 2, or S is 2 and T is 1. Again, we are not interested into S and T. We do not know, we do not care whether S is 1 or T is 1. We do not care whether U is 2 or X is 1. We don't care about that. The point here is that U and X are either 1 or 2. U and X are either 1 or 2 because they have to add up to 3. Because their sum plus the sum of the S and T has to add up to 6. If U and X are either 1 and 2, then R must be 3. Then R must be 3 because each number must be used once in a given row or a given column. Therefore, second statement is also enough. Second statement is also enough. The answer is D. That's all. The answer is D. Perhaps I explained too much, but what can you do? I'd rather take this chance than the other way around. I'll see you tomorrow, okay? Bye now.